Alright, so in this information we can pull from it, basketball player is trying to make a half-court jump shot and releases the ball.
171.
71.
Someone
So, assume the ball is launched at 51 degrees. So, the ball is launched. Some initial velocity, 51 degrees. And above the horizontal and a horizontal distance of 14 meters from the basket. So, here is my initial position in the X direction. Make that 0 meters. And it ends over here with my final position, which is 14 meters.
Why do you have the little... Oh, okay.
Wait, why'd you make it that long?
I just did it to do it. Nothing in particular.
Okay. What does it say under the 51 degrees with the quarter A's character?
It's like they're starting.
Initial position is 0 meters.
Okay.
Alright, now in this is popular things tell you we're going to need to break these down into X and Y components because I'm going to use them to solve. So here's the interesting thing is you can't do what we normally have done before.
Can you move the paper like down just a little bit? Oh, okay.
Can't do what we've done before. Like in typical cases, we take this resultant vector and we solve around for this. But in this case, this is actually what we're trying to find because the question says, what speed must the player get the ball in order to make the shot? Now, I'm going to go on and tell you there's probably more than one way to do this problem, but this is the way that I figured this out. So I did some math here. So the initial velocity in the X direction, the orange, is equal to the initial velocity, which is that resultant vector up there, times the cosine of 51 degrees.
I had a question.
Yes.
Why couldn't you use like the meters, like the
That bottom part where it's like, the bottom part how it equals like 14 meters. Is it because it's in the X direction you need the Y direction?
Yes. If that was in the Y direction, we'd be set.
Okay.
Then we have the initial velocity in the Y direction is equal to the initial velocity times the sine of 51 degrees. So in this now, we can label some information down. I'm still going to do our list of X direction. And we have our Y direction. And is initial Y final. Initial velocity Y, final velocity Y, acceleration, we don't say it's gravity, it's squared, and we have time, which we know. Our initial position in the Y, we go and call that 0 meters. Let that work out really nice for us. Okay. Final position, if we look at this as a whole, so we're looking here to here, the position's the same, So we could say that we want to do that in 0 meters. Initial velocity we do not know, and a final velocity we do not know.
Why would it be 0 meters for why? For both of them?
Because he shot at this point, and the basket is at this point. Or she, he or she.
Okay.
It's funny because you would not have said that if you wouldn't have been in that class.
But Mr. Hall, why did you like shoot at the same level as the basket?
We see this person, either he or she, is super tall. And they got some super long arms, and it's at the same height. It's probably Yao Ming in the shot as well. I don't know, but they did it just to make the problem simplistic for us, so that we didn't have to worry or be concerned about all these
It might be like a
changes.
7-foot tall person on an 8-foot goal with their arms up.
Yeah,
Good.
I guess that's how I think of it.
There's so many options here. Only
So
thing
like,
we know
you
is the
just say
same
like,
height.
All right.
Same height. So, in this, we do have an identity that we have figured out for the initial velocity in the y direction, which is the initial velocity times the sine, 51 degrees. And then we'll fill in one for over here. So initial position in the x is 0 meters, final position in the x is 14 meters. Then we got initial velocity in the x, final velocity in the x, acceleration is 0, time we do not know. Now, just like we did for the y, we do have an identity for this initial velocity in the x. We found it to be the initial velocity times the cosine of 51 degrees. So this can help us solve some things. Okay? I'm going to be honest with you, which I don't doubt it, y'all are smarter than me. Y'all can sit here, fool around with all those equations all day and night if you'd like to. Give it a shot. I do not see us coming up with any way to use those equations that we have So you texted me about having issues with ProPresenter. We'll figure it out. Anyway, so in this, we got to find a relationship somewhere, and this is the issue that we come into, is there's too many variables and too many situations, so we need to change one thing around to where it's going to be one variable overall at the end of the day. And this right here is what I said, we're trying to find this initial velocity, let's make that our variable. So to do that, I first said let's start in the y direction. So we're going to have to move some things around to where it'll adjust and work for us. So working in the y direction, I ended up going with this formula. Final velocity equals initial velocity plus acceleration times time. The reason behind why we do that. Is we're going to move stuff around and find this time to where we have an identity that we can plug back into the x direction in order to find this. Now this is out there in all of the maps, so I pray to the good Lord above that you are paying attention. That's your attention. So you move this thing around, you get time is equal to final velocity minus the initial velocity divided by acceleration, which we know to be gravity.
Wait, is it final velocity minus initial velocity all over gravity or
Yes,
just initial?
all over gravity. It's all over gravity. Now, in this case, this is what we're going to end up with. We're going to find this time. Since we're at the same point here and here, the ball has traveled the same amount of distance. If you remember back when we did those free fall diagrams and free fall problems, we talked about a tennis ball leaving my hand. The velocity that it left my hand with is the same velocity it'll have whenever the ball hits my hand. Right, good.
So you just make those zero?
No. Final velocity in the y direction is also the initial velocity times sine of 51 degrees. But there's only one difference. These are traveling in opposite directions, so they've got to have an opposite sign, which means we're going to have to choose what's going to be positive, what's going to be negative. And I'll let you choose.
Down and
So we're doing down is negative.
no.
All right, down is negative, which that therefore makes our final velocity negative and our gravity negative. So now we can plug this stuff in. So this will be equal to the final velocity, just subbing in the negative initial velocity times the sine
Wait,
51
can you just
degrees.
multiply it by 2 for it's a negative subtracting a positive? Like, no, never mind, I flipped that completely in my head.
Minus initial velocity, which is the initial velocity times the sine of 51 degrees. This is why it's important that you make sure that we keep this same.
Do you end up getting 2?
Yes. Which I think is what Chloe was jumping for.
Yeah, it just
I'm just going to leave that as gravity. I know all of you in this lovely room, you love to do the math thing. You want to plug all this stuff in and run for it. That's your choice. I'm just going to leave gravity because I'm going to have to substitute this thing into another thing. So simplify it out. This minus that will be minus 2 of that. So we now have an identity for time. So I now can take that and plug up here for time. So I'll fill it in. Minus 2 times the initial velocity of sine.
Wait, shouldn't that be on the side of time of the y direction?
But time is the same in the y and the x.
Okay.
So this does fit in here, but I'm done with the y, so I'm not going to fill it in anymore. I've solved something for the x what I'm looking for. So now, comes the fun part. So ultimately what I got a final position. I have an initial velocity for the x, and I have time. I also know acceleration. So in this case, I'm going to jump for the final position is equal to the initial position plus the initial velocity times time plus 1/2 acceleration times time squared. This is why I'm going to jump for that. Initial position, 0. 1/2 acceleration times time squared, 0, because acceleration is 0. So we now end up with...
Wait a second.
Yep.
Okay, you said acceleration 0.
Yep.
What do you? Oh, okay, well, the x direction. Never mind.
And then you move that around and then you get the answer to velocity. Don't you?
Oh, that's velocity x gives though. Because in this we're going to do some substitute. Because we're trying to get everything in terms of this initial velocity here. So in this case,
Pardon the interruption, but I need to let football players know that the weight program this evening has been canceled in case you need to call home. Also need to see Alyssa Bailey in the office.
so final position is equal to initial velocity times time, which from the identities above, we get to be the initial velocity times the cosine of 51 degrees. And this will be times time, which we found to be the initial velocity. I'm sorry, it's -2 initial velocity times the sine of 51 degrees. That quantity is divided by gravity. And that's equal to 14 meters. Well, this works. This works. Yes, you're right. Okay. So just to clean it up some, since you can see it, 14 meters is equal to the initial velocity times the cosine of 51 degrees. That's times -2 initial velocity times the sine of 51 degrees, and that's going to be divided by gravity. So this now has set me up where I only have one variable I have to solve for. It's yes. Oh, I'm sorry.
It's okay.
Yeah, I was about to say, I was like, oh, I can do that.
Anyway, so we cleaned it up. 14 meters equals initial velocity times cosine of 51 degrees times quantity, -2 initial velocity times the sine of 51 degrees, all divided by.
Madison Hatfield Senior to the office.
Okay?
Gotcha.
That turned dark.
Yeah.
Okay. And an AF popped up. I don't know if that means anything.
I tried to focus it. Alright, anyway, hopefully you still see it. Okay. So in this, now we got to rearrange everything around to where we can get these initial velocities together by themselves and solve for it. So we're going to get, man, I should have known to plug that in. You can leave it in there if you want. You guys like to plug it in, I don't. So I'm going to leave it as the final position. So in this, we're going to get the final position times gravity. I can do that because all of this is being multiplied together. Is equal to. This is where life gets fun. So all of this is being multiplied together. So I'm just
So
going
it's
to
gonna be
make -2 forward. Initial velocity squared. And it'll be time cosine 51 degrees times the sine 51 degrees.
Why is this so complicated?
I don't know, it's just a good problem. There probably is an easier way of doing this, I found a way to work it.
so you got the squared because you multiplied the two together.
Yeah.
And you just okay.
Alright, so now we got to get that initial velocity by itself. So initial velocity squared is equal to the final position times gravity. That quantity is going to be divided by I think for a second. That's going to come over. So this will be -2 times cosine of 51 degrees times sine of 51 degrees. That quantity. So we ultimately end up with the initial velocity is going to be equal to square root of final position in the x direction times gravity divided by -2 times cosine 51 degrees times sine 51 degrees.
This is way too complicated.
You guys should feel smart solving this. That's a good problem. Okay, now I know you're probably going to be like me. You're automatically going to look and get concerned about that negative sign. But remember, gravity is also negative.
So it's gonna cancel.
So they're going to cancel out before we do the radicals, so we will not be left with an imaginary number.
Wonderful.
Alright. And so we put all this in and then we got our answer.
You got it.
Literally, because
Light bulb. Why did this have to be so long though?
So we'll rewrite this on another page. So all I did is rewrote that on the page. So everybody should be good there. Do what?
same. I ran out of paper. I mean, I ran out of room, so I had to write it on the back.
So, initial velocity is equal to, now I'm going to start plugging these numbers in. So it is 14 meters times a negative 9.81 meters per second squared. That quantity, okay, 4/2. That whole quantity is divided by -2 times cosine 51 degrees times sine 51 degrees. And then we'll take the square root of that. Okay, so cosine 51 sine 51. Close that, close that. And I get 11.8494 meters per second. This
What do you get?
11.849. That's our answer.
Genius.
Woo! Mic drop.
Panda. I think.
And so as you guys can see, is I threw those negatives in. 233.
I don't do good with negatives.
Yes, you do. Are there questions here? And I can flip back to the other sheet.
Honestly, I see where you got. The problem with me is I see what you're doing once you do it, but for me, it's just
I can do it.
we're getting
Get it on my
started.
thought process.
Yeah.
Remembering what steps to first and all.
Yeah, this right here is one of those problems that it's like, I mean, it's deep thought. I mean, you guys literally seen me yesterday, sitting in here figuring it out. It took time to think up a way to solve this. But that's where I tell you guys, stay calm, there's a way to do it, just find it. And I kept trying everything, and then I said, the substitution method has to work. There has to be something I can substitute in here and give me one variable by itself. So what's the one thing that the X and Y have in common? Time. So I found a relationship for time that I could plug back in. And we did. Might be bored, I don't know why. Okay? That was a really good problem.
Usually I just don't follow you when you like manipulate the equations and I like fill them in. But for this one, I had no idea where you were going with it. So I just did what you did.
Okay. I did record this so that I could throw it out to you.
Okay.
Probably tomorrow before it gets thrown out to you guys, which is a guess ball.
Like this one.
Probably, no hen.
The number 3.
Madison's a little bitter.
It'll be number 3.
No more feelings.
It's like Dylan will get it right and the rest of us will get it wrong.
I feel like you can get this deal.
But
Yeah.
I feel like we wouldn't have enough time to do that big of a
Oh,
problem.
you absolutely would. This is a lot of instruction that went on in this
I mean,
problem.
we finished that, and it's only 233.
See, look at that. Okay? We didn't even get started on time.
Dylan, it's 236.
It was 233 when we finished it.
No, but it took you like a whole entire day.
I know. But, instruction went, this is the thing. Will I give you one like this on a quiz?
Yeah.
Once you learn it, don't forget. All
I didn't research. You know what I'm gonna do?
He's
Take
gonna
this
give
and
us
stab
like
it
a
in your
chemistry
shirt.
question.
I'm like, just
Once you learn it, don't forget.
I swear.
But see, I can't do that because Julie and Taylor's in here and they have information. Unless I wrote them their own quiz.
No.
I'm just kidding, I won't do that. I'll be honest with you guys, in all honesty, I do, I gotta say, I side with Savannah on this. This problem takes too long to solve, and there's way too much going on. This is very, very deep. I mean, look, it's the last projectile motion problem I gave you. So it's very, very deep. I won't give you one like this on a quiz. But this is a very good example of a thought process to work through. Okay?
Again, if you make copies of your notebook and sell them, I'll buy it. I take notes, but sometimes they get a little lost.
Hey, Mr. Hall, can I run the council officer?
Sure.
Woo!
Question number what we're doing again.
We're all.
58. Alright, now in this, we're jumping into something else here, okay? 58 on 171, we're going out of projectile motion. So we're done with the projectile motion. You guys, I feel like you got a good grasp of that.
So this is circle.
This one's circular motion, okay? Like at
It's
the
gonna
time
be
when we talk
important.
about spinning the keys. So in this, it should start off a little easier for you. Alright, won't be as bad. So in this, you have a 615 kilogram racing car. So we have a mass, 615 kilograms. This racing car completes one lap in a time of 14.3 seconds of time. 14.3 seconds. Around a circular track that has a radius of 50 meters. So radius is 50 meters. Assume the race car moves at a constant speed. What is the acceleration of the car? Now it's been a hot minute for me. So on A, when we're trying to find that acceleration, so remember that I'm pretty sure it's called centipedal acceleration. Centipedal acceleration is equal to velocity squared divided by the radius.
A centipede, what?
Centipedal acceleration.
What?
Is it like centipede?
I want to say
I'm sorry,
centrifugal, but then they all say centrifugal is not real.
I don't
Not
remember
real
this.
word.
Okay, what does the C have?
Centipede acceleration.
Mr. Hall,
That's just saying it's circular.
Okay.
I might be thinking about this like too mathematically, but couldn't you just like where the track is circular, couldn't you just get the circumference of the circle and that would be how much you have to go around it?
So you then have a change in position,
Yeah,
and you have the change in time,
yeah.
and a change in position over a change in time is velocity.
So is that right?
Yeah.
We're gonna have to find the circumference.
Yeah.
No, it's not hard. It's 50. It's radius. So
I know, but I'm just saying, like,
I thought I did it wrong, but I was like, mathematically speaking.
R equals.
Circumference. Isn't that
Pi d.
pi d, right?
So pi 100, so 314 change. 314
and change.
This is pi followed by.
the circumference over diameter. 323. OMG, can't you see?
And I get 314.1593 meters. I use the pi key. Or that 22 divided by 7. I don't like using the 3.14 abbreviation because, hey, we got some more digits there. Alright, so there's the circumference, so we need to find velocity. So velocity is equal to the change in position over change in time. The change in position we just saw for 314.1593 meters divided by that change in time, which was 14.3
Okay.
seconds.
How is that? Okay, never mind.
So velocity is equal to 21.9692 meters per second. So now we can find that centripetal acceleration, which will be equal to 21.9692 meters per second. That's squared divided by radius. And the radius was 50 meters. Square that, divide that by 50. I find centripetal acceleration is 9.6529.
Kenna Ellison to the office, Kenna Ellison.
So there's A. Then we're going to look at B. B asks,
What force? Force equals a mass.
force equals mass times acceleration. It doesn't change, even though this is centripetal acceleration, force equals mass times centripetal acceleration. So the mass of the car, 615 kilograms, times centripetal acceleration, which is 9.6529 meters per second squared, which will be equal to 5,936.5316. Somebody remember the units for force? It's supposed to be different.
Kilograms times.
Newtons.
Dylan, don't.
Is that the answer?
That's the answer.
That was pretty good.
See, I can do that.
Yeah, see, like, if you give us a bunch of those on the quiz, like,
Oh, I give you a bunch of those, please.
He's not even gonna give us one.
Hey, I will say on this, in case you go home and you're solving this and you look at it and you're like, that's not the number I got for doing that. That's not the number I got for that. I literally saved the answers in my calculator and ran through it. Okay, so just so you guys are aware of that.
That's close.
All right, this is what we're going to do. Okay, it's 2:44. So